refrigeration when it first started back 100, 150 years ago was complicated, but now we work on system that, oh, it's just a regular refrigeration system, not too complicated. We're just continue to evolve, right? And so it will be
Yes.
complicated now, but in 10 years, it's not going to be as complicated,
And the technology keeps catching up with what we're trying to do. And if there's a need for it, then the technology will be there that'll help fill it. I mean, I even go back to think about our first racks and everything from the discharge of the medium temp up to the gas cooler or adiabatic and down with steel pipe of some kind, stainless or with some kind of steel pipe. Now, at least when we manufacture, we use the copper with the steel alloy in it. And the
Mhm.
contractor can use that same material. So if he's comfortable with brazing and doing copper, it really doesn't substantially change it. The material still brazes the same way. It's a slightly different way you go about doing it, but it's really no different than a braze joint you'd have now. And a lot of folks don't realize that's only that one area of the total system.
Welcome to another CO2 Monday and the Refrigeration Mentor podcast. I'm your host, Trevor Matthews. Once again, I want to start off by thanking all of you for taking the time out of your day to hang out with us, to learn a little bit about CO2 and just brush your knowledge up, because we've been doing this week over week, trying to learn a little bit more. And each week I bring in some of the top guests from around the world, and hopefully you're getting something from this, writing some of this stuff down, taking some notes. That is really important, because as we continue to move on forward in the refrigeration industry, we're going to see CO2 in more and more application. Today, I got a special guest from Heatcraft. Actually, this Grady, his name is, he started in the industry over 40 years ago. So I did a little promotional thing and I said, oh, 34 years, but that's actually just working for Heatcraft. He's been in the industry over 40 years. Grady is the leader of the Northwest cold storage sales, and he's here today to chat with us about CO2 cold storage applications. Grady, welcome to the Refrigeration Mentor podcast. How you doing?
Doing well, thank you, and my pleasure to be here today. So,
Awesome. Well, why don't we just start off and talk a little bit about your journey in refrigeration and how you got to where you're at today?
yeah, look, the long and short of it is my dad was in the business. I had gone to college. I was a chemical engineering major for a full year. Felt that that wasn't the direction I wanted to go for the rest of my life. I wanted to go, find something else to do. Decided to go work for my dad for a while in his business. He came from a background in dairy processing, refrigeration equipment, was early stages in Florida in convenience stores. And that's where I then went to school for training, got certified in it, became a state certified contractor in Florida. And that's how I got into it. And I sometimes jokingly say refrigeration to me is like a cult. Once you get in, you never actually leave it. You might move around within it, but you seem to never leave. And that's exactly what happened to me. And then starting as doing service and installation and actually working on the equipment led into getting into the sales side of the business, which I've been in now for the 34 plus years. So,
Awesome. Awesome. Well, let's dive into it. When did you start learning about, because you've been in the industry for a long, long time. When did you
right.
start learning and seeing about CO2 now? Because CO2
Yeah.
is not nothing new, right? Like we keep thinking of, when we're talking all the time, new people come and it's like CO2 is kind of new. CO2 is not new. So when was it when you first started seeing CO2?
Yeah, a little bit. I have to guess here a little bit, but it's probably been about 6, 7 years ago when I kind of really started to hear it and really got interested in it and began to explore it a little bit more. Like I came up during a time, and this will age me a little bit, but I had R12 and I had 502, and you could take on the world and do almost all the projects we were doing at the time. And so been through the transition to R22 and then to the R404s and 448s and 449s and the interims and all the other ones that were
Yeah.
out there over time. So I've seen a lot. But the company was moving ahead with it. At the time, Kaiser Warren was a sister company in the Heatcraft family. So they were doing quite a bit of CO2 on the supermarket side of the business. And then did one interesting project that was an ammonia high side CO2 secondary that got a lot of write up and all about it. And that's when I really got interested. That one was down in Columbus, Georgia. They were CO2 subcritical in this situation with an ammonia topside, but very low charge. And then it really has gone from there to where the more traditional side of the Heatcraft business then began to look at what can we do with CO2 and where can we go with it. And it's coming up now about 5 years from our first initial startup on a cold storage related project where I've spent my time with CO2 with Heatcraft.
Awesome. Yeah, awesome. Because CO2 is in all these applications, from residential all the way up into the industrial cold storage area. And it's important to understand that we're going to see them in these applications. Why don't we talk a little bit about the different cold storage application that they'll be in? I know last week or 2 weeks ago you were at the RETA
Right.
convention, and you did a good presentation on the different, well, four different applications that you guys work on. Why don't we talk about a little bit about the different applications we could see this in?
Sure. And the Rita was a good example of we were still just trying to get some exposure out there. So we just gave kind of a quick overview of four different type of projects that we had done to show different ways that you could apply CO2 and projects that we had been involved with ourselves. The very first one we did was a cheese production facility in Wisconsin. Used a air-cooled gas cooler up there with their lower ambience. It worked fine to do it. All of the projects we've done have all been transcritical CO2 booster systems, parallel rack systems. We've done other processing facilities, some as large as up to around 500 tons. Our smallest was actually a unique one. It was only 35 tons, but it was actually just for one room, and it was for a spiral freezer application. And then another unique one we've done is one that actually wasn't for any kind of food processing or otherwise, but it was for a production facility. And what they actually needed were two different chilled fluids for their production facility where they do some things with molds. And as the molds are finished being poured, then at some point they have to quick chill them to get the product out of the mold. And that's where our secondary then fluids were cooled to do that work. So we've done mostly storage and food processing type applications, but have also done a production facility as well at one point. So.
Awesome, awesome, and I know I've been talking with the Heatcraft team lately, and I didn't know how big I guess the Lennox International family is and how involved they've been in CO2. And recently, I was told that you guys have this new branding of Magna. Can you talk a little bit about that?
Yeah, Magna is relatively new for us. We've been in the market really right about 2 years now with it. And look, we've been very well known for many, many years with our commercial brands with Bone, Larkin, Climate Control, and Chandler. I came up myself as on the Larkin side of the business as originally a sales engineer, and that's where 8 years prior to that as a customer of their equipment. So it was a conscious decision a couple of years ago to say, where can we grow as a company? We're always looking for new growth opportunities. And we decided to look and get into the industrial market. So it started about 5 or 6 years ago with actually looking at new products to bring to market, larger capacity, more robust products that they really wanted in the industrial market and things that were important for that. And then launched about 2 years ago. So kind of tricky timing, launched right as the pandemic was hitting and with all the supply chain issues and everything else. So it's been a fun couple of years and a challenging couple of years, but we continue to make headway with it. And so now Magna is basically just our industrial contractor product line, building on our reputation and history that we've had for, in some cases, over 100 years in the commercial side of the business.
Yeah, and that's one amazing things. As companies grow and as they evolve, they need to start to brand different segments of the markets, and I think it's a great idea because this that side of the market for CO2 is going to grow substantially. Ammonia, that's a great refrigerant. It's not going to go anywhere, but there's a place for CO2 in the industrial side. We're going to see more and more of it happening.
And actually, that falls right into the niche that we were trying to fill with Magna. We look to go into that 100 to 300 ton range. We're not trying to compete with the large ammonia projects. Currently, we have no plans to get into the ammonia side of the business, and CO2 fits very, very nicely in that one there. As mentioned, we did one project that was 500 tons with several racks on it. But we're now developing a platform that will have up to 250 tons in one rack. So we continue to grow the platforms as kind of the market pulls us into it. But we see CO2 ongoing to be a much larger part of our cold storage portfolio.
Yeah. And what I really love that you have that technical background. You've been in the field, you understand it. So when you're out there working with your customer, working with your client, you can think about both sides of it. You can think about what the contractor really needs and what to help them, as well as what that end user wants from all your years of experience working with different customers. Why don't we talk about some of the applications that you're seeing now that you're involved in, the success of them, the challenges with them, and how you're going tackling some of the problems that you see?
Yeah, and look, we've got two or three large projects that we're in the process of have in the manufacturing schedule and we'll come to market with. One of them is going to be a larger grocery store, and they're over time going to convert all of their storage facilities into CO2 as their intent. It was going to be a very large project to try to do at once. So they've literally broken it down into multiple stages. So we're doing phase one right now, which is basically taking a certain portion of the facility, and we're going to work that one. I'd say the challenges have always been how aware is the contractor with it? How aware is the end user with it? So let's even go back one step further. Usually it's with the end user is, okay, this is different than anything I've done. I might be very familiar with HFC refrigerants. I might be very familiar with ammonia. So now CO2, tell me about this. What is the difference? What do I need to be concerned about? What do I need to know? What do I not need to be concerned about? So I think getting involved early has been our best outcomes with it. Usually connected at the hip with the contractor that will be involved with the installation and hopefully the aftermarket support. If not, bringing that contractor in as well as quick as we can, and really just having open discussions about, look, CO2 is a great refrigerant. The biggest challenge is the high pressure, and the high pressure sounds kind of scary to some at first, but when you really see that high pressure only exist in certain part of the systems, and with today's materials and other things that we can do, it's very manageable. We've done it now multiple times. That helps our story as well. When we say we've done them, and we've done them in a variety of ambient locations around the country. So I think that's the first step, is get everybody involved, make sure everybody's comfortable with it. And then for the contractor in particular, making sure he's got that training, and particularly if it's the first one that he's done, to understand how to handle it safely, how to properly charge the system, how to, just handle the refrigerant itself first. Once we get past that, find that the rest of it goes fairly easily. And they find at the end of it, they say, this isn't that much different than we've had before, with a few nuances, but they appreciate that time invested on the front end to become comfortable with it.
Yeah, and I think that's the most important thing, is that upfront time, being upfront with them. Like, there is work. It's not easy. You got to learn something new, something different.
Yep.
The high pressures I hear all the time, but the same thing as you said there. After they learn a little bit about it, they work on it a little bit. I continue to hear more and more technician contractors say, "Man, I way rather work on CO2 systems than the old HFC systems that I've been working on." Yes,
Yep.
it's scary up front because, like you said, the pressures, but when you think about it, it's like you just said, it's on certain parts of the system, and
Right.
if when you understand the whole dynamics of the system, you know where it's at. Okay, I know that 1500 psi is running through these pipes. Okay, so that's step one. Now how do I deal with the rest of the system? And really, it comes back to that knowledge of how refrigeration systems work, the different components, the different strategies that are behind it. But I think that's step one. So that's one thing that I see a lot of people that are even manufacturers that they have a challenge with, is the knowledge base on CO2, because there are a lot of contractors that are really good in refrigeration, supermarket, industrial, whatever. But when you throw that, like you said, that wrench of CO2 in there, now there's a little twist that we need to learn a little bit more, something new.
Correct. Yeah, absolutely. We've seen that consistently, and I'm certainly, without saying any names here, but we've had those that have really invested on the front end and have had very, very good experiences from the very beginning all the way through. We've had some that maybe hasn't been the case, and it's kind of obvious why. They were literally learning on the fly when we were going to do startups, and it was a little too late in some cases to make it a smooth startup at that
Yeah,
point. We're huge on training, and we
I love
love
that.
to offer training. We know that's important, and actually we continue to launch more and more programs, both on the awareness side of what CO2 is
Awesome.
and on the technical side. If you're the technician and you're going to be touching the equipment, we're going to have specific training just for you. So,
Yeah, and I think that's so important. That's so important. And all the other manufacturers, what I like about CO2, it's bringing manufacturers together. Like, I was in Europe a few weeks ago, last month, and then all of a sudden, like, I was talking to all the different manufacturers, especially the CO2 companies, and they're like, they want to work together. You know what I mean? Yes, the competition is very important, but they want to work together in the CO2 side to help it grow the knowledge, grow the confidence and the comfort level for the technicians, the suppliers, anybody who's working on it with it, designers, engineer. And that's what I
yep.
really like about it, is bringing more and more people together back into refrigeration the way I like to see it.
Yeah, no doubt. And mentioning the European market, it was one reason why we have such a comfort level here as we begin to do more in the U.S., because our operations in Europe have used CO2 for many years. They're obviously several years ahead of us in it, so kind of been there, done that, gotten learnings from it. And so the product designs, the technology, the changes over time have been incorporated there. So it's a real plus for us as we got started into our own journey here in the United States and Canada with it as well. So
Yeah, and I really like that because, like I said, when I was in Europe, I was meeting people from your team that had years and years of experience already, and I didn't even know they were part of the family, your family, like the Heatcraft and Linux International family. So that's great.
right,
So some of those challenges, yes, is with the knowledge base, both on contractors and user, and I guess at a whole level because we got a lot of work. This is why I even do this. We got a lot of work to talk about CO2 to get the knowledge out
right.
there to help more people. After you get your application, your cold storage installed, you work with that contractor up front, and now that it's running, what are some of the successes you've been seeing with your CO2 systems?
Yeah, look, it's what folks have found is it's been an extremely efficient refrigerant for those, and particularly I mentioned a couple of cases, two or three cases where they're processing facilities. They have a high hot water need for their facilities to generate that hot water. If you don't have a heat source, means you're paying whether it's electric or gas to heat that hot water. CO2 is a tremendous source of heat. And if we're just dissipating it to get rid of it, and that's what we need to do when it's running in the summer, fine. But if you can find a way to use that heat, and certainly in processing applications, we've done it on almost every one that we've done very successfully and have such a good source of heat that in a lot of cases, I think they said, well, you're supplying about 80% of my hot water heating needs by this. So it was a direct, energy savings on the whole project. And honestly, it just makes the rack that much more efficient as well. You're finding another way to dissipate the heat before you go through the gas cooler or the condenser or whatever you've got on the roof. The second way you can use it is underfloor heat. If you've got freezers and applications where you need to warm the ground so you don't have heaving underneath it, again, perfect source. You've got it right there. So I think that has been one of the biggest ones to me, where we talk about that when we sell the projects, we do estimates and everything else. Once the owner operators who have operated with conventional systems for years get this and begin to operate it, they say, I see it. I'm seeing where my energy bills are. I'm seeing the savings, not only in the efficiency of the system itself, but what I'm getting secondarily now. I was maybe recovering hot water before, but now I'm getting so much more from the CO2 system. So one side benefit of having that high pressure, high temperature refrigerant for sure.
Yeah, and that's one thing that I love continuing to learn about CO2, and it's still evolving. Like people don't understand, it's still evolving. We see it using for a lot of different applications, like you said, underground heat or roadways, where trucks are coming in, you could heat the ground there, as well as now we're getting into air conditioning applications with CO2. So we have one system with one refrigerant doing so many different things to help a customer out in so many different ways. I love hearing that. Um, why don't we talk about? So you said you talked about at the RETA conference about 4 different applications. Which application has been one of the funnest for you to work on so far as the journey of that system evolved?
Well, I guess I'm a refrigeration nerd, so I think they're all fun. So,
Yeah.
I find them all to be a challenge. But, there was multiple different ones, and seriously enjoyed all of them. I think some of them, there was one that was a local food pantry. And so in this case, not a huge project. I think it was around 70 or 80 tons, as I remember. But knowing what the cause was for at the end of the day, the contractor was also very much invested. So we did some things to keep the upfront costs down as much as possible, made sure we invested in it. And to me, I said, this is a real win, because here's somebody that's doing great things in their own market there when people are in need and need, some help with their food and where they're going to get it from. To be able to know that ongoing, they're now going to have an extremely efficient refrigerant, completely void of any future code requirements, regulatory issues when it comes to the refrigerant. You just feel good about, applying it in that way and all the time that's invested in it. I'd say maybe a couple that were fun in the sense of being a little bit different. I mentioned the one with the spiral freezer because it was a single, relatively small load for a bakery that did unique applications, and to figure out how to do that one and to come away with it was a nice win and had good results there. The same with the one that we did for the processing applications, because that really In most cases, we're matching our evaporators or some sort of standard evaporator with it in the system. In that case, the CO2 rack went to nothing more than 2 heat exchangers on the rack that went to other fluids to use for a very, very different application for us, which was a company doing plastic molding, and how our cooling equipment or our secondary refrigerants were cooling that and allowing it to do their process. Again, they had ongoing machinery that had done it with HFC refrigerants. So they were the first to say this is incredibly efficient. It's working very well. And they were looking to increase the capacity of their facility. And our system was able to handle that beautifully. So,
Yeah, no, and I really like that. I love continuing to get different applications, different, just hearing these different ones that, a lot of people in my, like in the commercial space, we don't really talk about processing of plants and different molds and application, but refrigeration is huge in those applications. Um, I did hear you talk about, and I've heard about this from a lot of different engineers and the designers, and everyone has different opinions on it and how they design their systems. But when we design, we design a system, you're always designing for the hottest day, the worst case scenario. But then what happens in the middle of winter when there's no load and there's nobody in there? I know different people take different approaches. And I was hearing you at the RITA convention talking a little
yeah.
bit about your guys' approach on how to tackle low load situations, or your customer goes in and shuts down a whole section without discussing up front in the details. Well, we plan on shutting down 75% of the plant on the weekends. What are some of the strategies that you guys came up with to tackle that?
Yeah, some of it isn't any different than we've done traditionally with HFCs, but I think it does become a little bit trickier with CO2. And you're right. I remember during the conference at RITA where we had the talk there, I brought that up. I said, look, it's easy to size to the highest load. That's kind of, first of all, you have to do that. You've got to make sure you've got enough capacity on the worst ambient day at what you expect would be the highest load that you're going to have on your facility. But the tricky part becomes handling just the opposite, the lowest load on the lowest ambient. They don't necessarily go together at the same time, but it's again where having more visibility of really understanding the facility on the front end is very, very important, and how they're going to operate it. It's one thing to say, okay, I understand I've got these different rooms at these different temperatures, and I see the load profile, and here's what we've got. Knowing though when you're going to have the low load is a tricky part. That's the one that becomes tricky. Now, a couple basics that we do is on any given suction group, our first compressor is always going to be a VFD compressor. The choice then is how small do you go? And then the real trick might be maybe you use a couple of smaller compressors on certain temperature circuits, and maybe multiple VFDs on those as well, to really dial it in. You want to be able to successfully run at that very low load without compressors constantly cycling, or just not having the ability to get down to where you can properly match the load. That's where it becomes a little bit more of a struggle with the control system and how we try to do it. Again, knowing that up front, we can design for it, and it's easy enough to design around. You just have to have that knowledge on the front end.
Yeah, and I see this a lot, especially like when you're starting up a system too, because there's no load in the system, and really, when you're starting it up, things are banging on, banging off. But when you have everything loaded up and then you get that low load, that's when lots of concerns are happening. So it's good to talk
Yeah,
about that, because sometimes you have to change stuff, right? After the fact, when you learn new knowledge on a system, and it happens, but it's being open, honest with the customer, walking them through, talking, and figuring out a solution together, right? And I like that part.
absolutely. Much more efficient to do it on the front end and have it there. And even if it's a little more costly on the equipment, going to save you a lot of money in the long run, as opposed to trying to go back and say, okay, we understand what you're up against now, but we're going to have to help you kind of design on the fly. How do we kind of fix the low load situation? One other thing I might bring up, because some folks might appreciate this, I did when I was there. The very first startup we did, I was there. It was literally the coldest temperatures in Wisconsin in over 30 years. It was minus 30, I think it's minus 38 actual temperature, with a wind chill over in the minus 50s. On the day we were going to start up from a dead start, the first CO2 system we've ever done. And the contractor was like, do we need to put this off or anything else? And our guys that were there, our engineers said, no. So one of the benefit of a high pressure, high temperature refrigerant is they don't really concern themselves too much with very low ambience. And we literally started that rack up from scratch. And within 10, 15 minutes, our flash tank was at the pressure that we needed. and we were off and running as the refrigeration contractor's phone was ringing off the hook that all of his traditional HFC systems were not coming on because they couldn't hit the set point to turn the compressors back on at that low of an ambient. It was pretty telling. And also in hindsight, I'm glad it worked out like it did because it kind of proved some things
Yeah.
out along the way as well. So,
Yeah, well, that brings confidence in your product and confidence in the contractor because that's something that we've all dealt with. Those cold days. That's when you're on call. That's when you're going out to a site.
yeah,
Usually is because stuff is not
yeah,
working. So that's pretty cool on the design up front. You understand you can design for whatever it is, right? VFDs, smaller compressors, whatever you need. What are
right.
some of the other options that you're offering your customers? Because it's not only the cold climates. This is where CO2 works best in cold climates like
Yes.
Canada. But when you start to get the warm climates, what kind of strategies are you providing your customers? Because there's some that we all know of, like there's parallel compression, there's ejectors, there's adiabatic cooling, there's
Right.
mechanical subcooling. The list goes on. What are some of the options that you guys are providing?
Well, you just mentioned most of them.
All
I
of them.
think I think maybe the only one that haven't actually executed to, only because the requirements haven't caused, has been the parallel compression.
Okay.
But we absolutely offer it. It's designed. It's there if we want it.
Yeah.
But certainly several here recently with sizable lower temp loads in areas where mid 90-degree ambients were clearly going to be possible. It was a combination of subcooling for sure that we did for the low temp to mitigate that load before it got to the medium temp compressors. And then in those situations, almost always we go with an adiabatic condenser that we pair with it. Obviously, get the benefit of that. What's usually interesting though is even on the areas that are warmer ambients, if you actually look at the percentage of time that you won't naturally be subcritical, it's still pretty low. Obviously, the one I mentioned in Wisconsin, I think it was around 95% of the time, just naturally with nothing more than an air cooled gas cooler. Others, we've clearly had to go with adiabatic condensers to keep that ratio low. But in all cases, it still ends up being a relatively small percentage of the time. I don't think any of them have ever gone over where 80% of the time we weren't naturally subcritical coming out of the condenser.
Okay, awesome. So, do you guys design the adiabatic coolers, or do you sub that, lease that out, like get that from
Uh,
somebody else?
yeah. Currently, what we do is we actually sub that out.
Okay.
But what we'll do is we're certainly involved on the design side. So what we can do is say, okay, here's the impact it's going to have on the rack. Here's what we're trying to achieve. So we work closely with some folks that'll
Yeah.
say, okay, we understand what you want, what you need. And actually, I think in every application we've used the same manufacturer for them all the time. So creates a little bit of marriage there. We do our own gas coolers when we can, but we don't force that, and we don't want to do it only to have a system that's a little more inefficient or is going to have potentially more issues when you have a high ambient day. So,
Yeah. So for adiabatic cooling, you can't just use that everywhere either. So this is one thing that I want to talk, you need to understand the products that you do sell and that you do offer your customers because this is super important. Why don't we talk about the different things about adiabatic cooling that you use? I think this is important for everyone is that because I understand, you understand that it can be in some applications for your customers and in some locations in in the North America, but other areas it doesn't work as well. Can you just talk on that a little bit?
oh,
You there? Sorry.
yeah, we had a
That,
glitch there for a minute. So,
that was probably me. Yeah, so can we just talk a little bit on the adiabatic cooling? In some
yeah,
locations, we can have adiabatic cooling, other locations we can't. And how do you work with your customer on that?
yeah. I mean, first is again saying, what's your ambient profile look like? What does your load profile look like, and where do we need it? I'd say in most cases, and by the way, I guess maybe this could be nuanced differences, some of which I might not speak to exactly right, but I'll give it to you in a broad way. You also need to see how can you operate your adiabatic condenser. Almost anyone that I've been involved with goes into adiabatic mode when it's needed, but short of that continues to operate as a dry gas cooler, basically. So that's really the best world in both, because then you
Yeah.
use the water when you need it. Water itself is beginning to get bigger an issue. And one of the projects where we used it was California. And in some cases, they're stricter on water usage than they are electric and efficiency. So you
Yeah.
have to find that sweet spot. Now, that was one that the adiabatic absolutely proved out. We need it, but we need the adiabatic. It was way less than 10% of the time with the natural cooling you have in the evening, entire months where you don't need it. but to bring that on. So yes, you've got to find the right balance between water usage, when you can use it, when you shouldn't use it, and when you can go with a more basic air-cooled gas cooler, which again, the projects in Wisconsin, probably up in the Canadian market for sure, probably is a good solution in most. But that's the trick. We need to find out, when to use which one. There's one application where it actually was a secondary fluid going to a water tower, basically. But we just went through an exchanger that went to that. So they had one on site already, and I believe that's the way they wanted to go. So there are multiple ways you can look at it. You got to balance everything into it. Energy, making sure the rack's going to get as low a condensing temperature as possible. Try to get as much liquid out of the drop leg as we can, but also take in mind what your energy profile and your water usage profile look like.
Yeah, and that's super important. It's just really understanding the products you have at hand, working with your customer, what they need, working with the manufacturer. For any of the contractors listening and technicians out there, you got to work with the manufacturer and really be upfront. Like you say, putting everything out on the table up front makes the projects go so much easier for everybody involved.
Yeah. Yeah, there are other things you can do unique as well. It's not really on the adiabatic side, but it did make me think as we're talking here. Though the one project we did, he knew the end user said, "I'm going to use my storage rooms, but I don't know when I'm going to need them as all coolers and when I might need some freezers." So again, he brought that up front, and so we custom designed where we dual circuited the evaporators and specifically had a low temp circuit and medium temp circuit. So we gave him the ability to switch with really a very basic little a changeover in their control system to do it. And that worked out very effectively. Again, if you didn't know that going in and you designed and then he decided to change his operation, a little trickier to do it at that point. So we were able to customize the solution for exactly what his operation was going to look like.
Yeah, and that's so important. Like just working together. I think that's the big thing in refrigeration work because there's so many dynamics, there's so many different things going on, so many moving parts. And when you really understand the fundamentals of what is needed and how to get there, working together as a team with the manufacturer, end user, and the contractor. This is awesome.
Right.
This is awesome. So you've been involved in cold storage application for a long, long time. So even before CO2, now we're moving into CO2 and really you're strictly focused on CO2 now in the cold storage, or are you guys for Magna, is that this specifically going to be CO2? Or are you working on the ammonia side as well, or?
No, nothing on the ammonia side, but certainly on the HFC side.
Okay.
And today, HFCs are still a bigger part of our entire portfolio. CO2 continues to grow at a much faster rate, though. So this last year, projects we were either involved with in terms of startup or that we have gotten new orders on exceeded what we had done the 3 years prior to that. So are they an everyday, this is our biggest mover? No, they're not. But the trend line clearly is steeper on CO2. Looking at future regulations and where we're going, we think that's going to do nothing but continue. California, with the California Air Resource Board requirements, makes that kind of an easier sell for the CO2 solution. Yeah. We think in the future, we're going to see a little bit more of a mix of some of the A2L refrigerants where we would use an HFC today, still use a more conventional condensing unit type of approach. But we think then when you get a little bit larger than that on the larger systems, that's where we think CO2 will continue to grow.
Yeah, and I totally agree with that. We're going to continue to see that line projecting up for CO2, especially with the regulation. I think so carb, I think it's anything greater than 50 pounds needs to be less than 150 GWP.
Yeah, it is. Exactly right. Yes. Yeah. Okay. Yeah, so none of the refrigerants today, including the 448s, 449s, are going to hit that. Some of the A2L refrigerants will, and it's not yet clear exactly which ones are going to be used. We're testing some now. We'll be ready for that, and it will fill some gap in the market. But again, I think it's a combination, and I think Europe has shown that as well in what we've seen from our European operations.
Yeah, and it's gonna continue to evolve. That's really what it is being knowledgeable, understanding. Because I still talk to a lot of people, and they don't understand even what's going on with the regulations. They don't understand some of it, and there's mixed feelings on it. But you got to work towards those regulations. You gotta continue to be knowledgeable, invest in the time to learn what you can and cannot use in systems. Because it's going to continue to change. Like here in Canada, we have one province where it's the same thing. It's 150 GWP for food processing over 67 horsepower, 50 kilowatts. You know what I mean? So we're going to continue to see this. And it's not like all the other refrigerants are gone. You need to understand that, but there's a place for each thing, and we're going to continue to evolve in all the different applications, which I like to see.
Right. Yeah, absolutely. Yeah. And matter of fact, for that, I don't know if we want to go there now, but there's one thing we now show or have is it is kind of confusing, because the other thing is right now, CARB in California is unique. But at least here in the US, there's about 23 other states that are part of the Climate Alliance states, which some are now looking at when their codes are going to kick in, but they're different. And so then it becomes very confusing. All right, this project's going in. What state is it going into? What's their code? What's the requirement? When does it kick in? And that can really change what we're beginning to talk about. Some of these projects, we talk about them a year, 2 years before the projects actually ever get completely started up. So you've got to be ahead of it and really know what direction things are going. So
Yeah, no, because for sure in 2 years things are going to be different. I can
right,
continue to see. I keep following, and every 3 to 4 years, there's even in the last 10 years, I've been seeing big changes happening, and they're just going to continue on. And
right,
that's the part of the industry. It's been happening
yep,
for a long time. It's not going to stop, but it's continue to educate. I know you were mentioning to me that you guys, Heatcraft, have built something just to educate
yeah,
the industry. Why don't do you want to show and talk a little bit about that?
yeah. Let me see if I can successfully navigate this here, but if I can,
Because you
it'll
guys,
work.
yeah, I can see it now.
I'm good in refrigeration, not good on IT stuff, so I'm glad that it works. So, so this is the website. You can see down here at the bottom. It's if you go to heatcraftrpd.com is our standard site. If you just put a /regulatory, it will bring you to this page. What we've tried to do here is just make an easy site to go to and constantly update it as we see new codes that are coming, what the dates are going to be. So I'll click on the link and let's see if this part will work correctly. There we go. So this is the site. One thing I like that we've done here is we've broken it down between the red dots show where the DOE has a requirement that's now impacting us. The green is where the EPA has a requirement that we have to go before. And then the yellow specifically is CARB or California Air Resource Board. Uh,
There's
but
so
then
much
it
on
kind
the
of
go
just gives,
all at once, right? There's just so much from different areas, different regulatory bodies, different associations. Uh, it's
there
wild.
is, and we actually, and give credit to our engineer and our marketing team for putting this together, because we tried to say, let's make this as user friendly as possible. You click on this button and it literally gives you, because it's so easy to throw the acronyms around,
Yeah.
but it'll tell you what are all the different ones that we're
Right.
talking about and why are they important. So it kind of helps you navigate it. More importantly, what it does when you come down here, this is a live interactive map. So as we know where codes are going to be. So right now I'm up in the Seattle, Washington area. I'll click on the state where I am. And when you click on it, here's what it tells you. The upcoming SNAP 23 step one is one that's going to impact them. So right now it'll number one tell you what refrigerants are acceptable and until what date. So you can see here, and you'll find this in several. End of this year, it begins to
Oh, it's
change
only
already.
5 weeks away, 6 weeks away. Some new
Correct.
regulations.
It already tells you which refrigerants are delisted you can't use, but then it'll give you a brief summary about what direction they're going and what the new code is and when we expect that the change is going to happen. We're involved with so many of these different groups and times throughout the organizations we're involved with. As we get new information, then we can easily update it. So yeah, you can go to whatever state you would want to go. Just clicked on New York. It shows where the regulations are, where they need to be. And then you'll see SNAP 23 a lot, and it's going to be one that's going to certainly drive a lot of change from the EPA. There's actually, if you click on that link, it will give you a whole walkthrough about what SNAP is, what the SNAP 23 breakdown means, what it would be the requirement change for you regulatory wise in your market, and kind of walks through which refrigerants are in, which ones are out, and then depending state by state when this would all go into effect. So, and again, it kind of references this site again as well. So.
Now, why don't you go over just Snap 23 just a little bit, just to give people that are listening on the podcast and stuff kind of an idea of what Snap 23 is, if you don't mind.
Yeah, I'll try this to the best that I can, but it's the next round of the EPA saying, look, we have to have more regulatory control and we have to drive out more refrigerants to get lower and lower as we go. So CARB kind of is on the cutting edge of it. They've already gone to where they want a GWP of 150 or under. That just screams for a natural refrigerant or a different solution than we've been using mostly today, the 448s, 449s, no longer will fit under that application. So it says we've got to do something different and something new. This is the market where some of the A2Ls could come into play and could absolutely fill that market. But those, again, will be a change. It'll be a new refrigerant. They are slightly flammable, not highly flammable. It's not like propane would be, but you still got to deal with it. And it's going to have some mitigation you need to do in case you do have a leak and how you control it. So it will bring some differences that the installer has to do on the job site just to make sure that everything is being handled safely so there's no issue with it. So at the end of the day, that's what SNAP 23 is now driving, is to that next level of what refrigerants are in play. What still seems like in question for some municipalities in some areas is what size. Some are a system over 50 pounds. There's some talk they could go all the way to a zero charge, saying it doesn't matter how much charge is in it. This is what we're driving to. These are still some of the things that are not clear. They haven't been finalized. They haven't all been put into writing, but it's all part of the direction that SNAP 23 is pushing us. Really, at the end of the day, it will delist the 404s, 507s, 448s, and 449s will all go away under SNAP 23.
Yeah, and this is why it's important to stay up to date. And I know there's so much going on out there, you know, and a lot of you are listening here or watching that things are changing rapidly, and some people are just giving up on it. Oh, there's just too much going on. You can't do that. You know what I mean? You got to take the time to learn this, because it's very important to understand where you're working, what you're working on, the trainings that you're going to need. You know, not only CO2 training, but then we just talked about A2Ls that are going to be there. What is the things that you need to understand about it? So there's going to be more and more training. And once again, we talked about it early. Training's so important. It doesn't matter what refrigerant it is. It's you got to be safe out there. You got to understand what you're working on. You got to understand the applications and how that you know, if you have everybody involved, it makes it so much easier.
Yes. So again, we try to take a leadership role to say, hey, we're going to try to give you awareness, try to keep you ahead of this. At least it's somewhere we feel you can go. As soon as we know there's been a change, we'll update that change and it'll be there. So we hope it becomes a repository that you can go and use and pull data that you might need for a project you're looking at doing here in the near future. So.
Yeah. Yeah. So what's the next step? You talked about those, a few of the cold storages that you're working on now. What is coming down the road? Like, what kind of projects are you going to be still working? I know your goal is those 100 to 300 ton size systems.
Right.
What kind of projects are you working down the road now that you're working on trying to push for CO2?
Yeah, I say there's a couple right now. You know, the platform that we've done to date was designed to go up to around 150 ton total capacity, usually with a split of medium and low temp. So now we're developing and we're about to launch a platform that can get us up to around 250 tons. So again, look, we've had projects. So we said we did one project that was 500 tons with multiple racks, trying to say, okay, what could we do where we could put that maybe into 2 racks? I think there's always some benefit to having full redundancy and to balance the load requirement. But the market is saying we need to get larger and larger in these as well. So we have a small platform that we could do down to around 5 tons to up around 20, one then that would go from there to the low 100s, and now a platform that hopefully get us up to 250. So that's one large one that we've been working on. I'd say the other thing that we continue to do as a manufacturer of evaporators as well is to continue to look and push what we can do in terms of how high our bar rating is for standstill pressure. So we certainly, a lot of the early ones we did were 45 bar. We've done 60 and 90 bar, which we can do now on a case-by-case basis. We're trying to move to a path now where more of our evaporators will have that more or less as a standard offering. They'll already be engineered, configured. We've got the right materials of constructions and the other things we need to change to get there. And at the same time, for somebody that maybe wants to go to 120, we're looking how we would design our systems to do that. We can do that today on the high side, the rack itself, to make it all the way up to 120, which honestly should handle almost any standstill pressure anywhere would be the goal there. Honestly, we feel that 90 gets us there probably in most applications. So we continue to build the products out to really say, where are we going to go? What do we need to do? So there's a higher and higher comfort level to go to CO2 in the future.
Yeah. And we're going to continue to see this. I've been seeing this for the last 5, 6, 7 years, where the products are starting to be developed more time invested in. Just like you're saying now, we're getting you started with 45 bar, but now we're up to 120. This is important because Some customers don't understand that you can't just shut off your system. You know, especially in the middle
Right.
of the summer when it's 30. You educate them and stuff, but it's
Right.
different than your standard HFC system, where there's things that you need to understand about it. You may have to have an auxiliary unit. You may have to have these different additions on a system to help maintain it without losing the charge.
Yeah.
So, and I'm going to
Yeah.
continue to see when I was in Germany too. I've seen a lot of 120, 130, 140 bar products, components.
Well,
And I really believe that that's going to continue on as more manufacturers continue to build that. And then I think it's going to give end users more of a comfort level.
yes.
You know,
Yeah.
that, okay, now if we need to shut down the system, same with the technicians and contractors, if I need to shut it down, I can just work on it, you know, at
Yes.
that pressure.
Yeah, and you had mentioned something that in one application early on we haven't used one since, even though it's been offered, is the auxiliary approach, which is you have a small unit with a a standby generator, and its intent is just to keep the CO2 in the system under a certain pressure.
Mhm.
Not for operation. You can't really continue to operate the unit with it, but you can keep it where you keep the pressures manageable, and that is something we can do. I mean, it's there. It's a a technology that's simple enough to do. It's just a matter of whether the customer wants to go to that extent or not with it. So,
See, and I think that's a whole education portion of it in training and knowledge, because I do CO2 trainings all the time with contractors, OEMs, and I'm training them. And it always comes up is like, well, what's the cost of the auxiliary unit versus losing a charge? You know, at the end of the day, for me, it's not only the auxiliary unit's not only for that. The auxiliary unit's for service. What if somebody needs to work on it and shut the system down? Well, you turn on
yeah,
the auxiliary unit. It's not only for power failures, and I keep getting people that, well, is there a generator on it? Well, maybe it doesn't need a generator. If you lose power for 5, 6 days, doesn't matter if it has a generator on it anyway. You're losing all the food. Like, it's not, your system's not going
yeah,
to be running. So I think of it as a service tool. I'm trying to talk to people. Understand, if you have one, it's a service tool for you. And more contractors that I work here in Canada, they have it on their systems. But I know I
nice.
talked with quite a few in the US that they say we don't have auxiliary units. But it's about the conversation. What the value is it? Can the technician save a lot of time by not blowing the charge on the unit, and they have the auxiliary unit? Because it takes a long time to charge a system. That's
It
what I
does.
tell them. Because there are some people I train say, Trevor, well, I just had to let the whole charge go, work on the problem, and then recharge it. But it's labor costs a lot of money. Charge costs a lot of money too. And some people say, well, CO2 less expensive than the labor rate, but you got to think about, I wouldn't want to be blowing my charge every time to fix a problem or something. Learn how to
No.
use the system properly, pump stuff down properly, isolate it in a section where you can use and work on it. And that's what I think the auxiliary unit's for personally, for a
Yeah.
service tool.
No. Good thought for sure. Yeah. Yeah. No question about that. And yeah. Yeah. Sorry, I lost my train of thought there.
That's okay. No, this is good. So really, any final thoughts on cold storage? Where you're going to go? How people can get a hold of you as well? We'll get into that, where people can reach out to you and
Sure.
Heatcraft. But what's the next step for you? I know that you're working on the 250-ton unit.
Yep.
I know you mentioned that you're using like all the different solutions, and you have parallel compression as well, but you haven't
Yep.
really got that engaged. I guess a customer hasn't really asked for it yet.
No. And same with ejector technology for that matter. We've got it. We're doing development with that. We've
Awesome.
worked with it. So far, haven't executed to one yet, but that again has been just the requirements that we've had. So ejectors, I think, will become a bigger and bigger part of the future as well.
Oh, 100%. I learned so much about them over the last 6 months, where before it was like, oh, they may be coming. No, I've seen it on almost every system when I was in Europe. Like, there's so many systems that have it, because the benefits are not only for when it's in the middle of the summer. You can also use them for heat recovery and stuff in the winter, and there's advantages of those there. But continue, and a lot of people think, well, it's just so complicated. Well, refrigeration when it first started back 100 150 years ago was complicated, you know. But now we work on system that, oh, it's just a regular refrigeration system, not too complicated. We're just continue to evolve, right? So it will be
Yes.
complicated now, but in 10 years it's not going to be as complicated, you know.
And the technology keeps catching up with what we're trying to do. And if there's a need for it, then the technology will be there that'll help fill it. I mean, I even go back to think about our first racks and everything from the discharge of the medium temp up to the gas cooler or adiabatic and down with steel pipe of some kind, stainless or with some kind of steel pipe. Now, at least when we manufacture, we use the copper with the steel alloy in it. And the
Mhm.
contractor can use that same material. So if he's comfortable with brazing and doing copper, it really doesn't substantially change it. The material still brazes the same way. It's a slightly different way you go about doing it, but it's really no different than a braze joint you'd have now. And a lot of folks don't realize that's only that one area of the total system.
Yeah.
Up to the condenser and back down again, gas cooler and back down. That's it. The rest of your piping to your individual circuits is really standard copper type of runs. And by the way, it's going to be noticeably smaller than if you used an HFC refrigerant. It's actually a cost savings on CO2 is the cost and the size of the copper that you need for the projects. So,
Yeah, that's huge. A lot of people don't think about that. One of the things, though, depending on where you're at in North America, will depend if you have to use stainless steel pipe or XHP or K65. Because here in Canada, you have to use stainless steel at this point, going
okay.
from the rack there. But I know in the States you can go with the K65. So just depending on where you're at, find that stuff out. This is stuff that you need to learn
Right.
and understand when you're installing these systems. But you had a good point too. Like these systems, you're using smaller suction lines, smaller liquid lines going out to the circuit. So you think about that, and this is where there's the cost benefit analysis, because lots of people say, well, CO2 is inefficient when it's 35 degrees out. Well, there's these warm ambient strategies that you could be using that potentially could save that cost penalty, I guess, you know what I mean? So
Right.
there's lots of cool things about CO2. Grady, this
Yep.
has been such amazing. I learned so much from you today, and there's so much more to talk about. You know, I'm excited to even to meet you and talk more about it. Where can people get a hold of you, get a hold of Heatcraft, find out more about Magna down
Yeah.
the road?
Yeah. Our website is Heatcraft RPD. The letters Refrigeration Products Division is what it stands for. So heatcraftrpd.com. You can certainly go there. My email address is my name, Grady.McAdams, McAdams at heatcraftrpd.com. So fairly easy, and love to hear from anyone for any questions, follow-up conversations, some thoughts on an application if you think it would make sense or not. Love to have it. Everything starts with discussions, and gosh, I'd say if we got every project we were involved with, we couldn't keep up. I mean, part of the process is dabbling the toe, doing some, looking at parallel quotes, HFC or CO2, and see where it goes. And we're absolutely willing to invest whatever we need to help move you along with your CO2 journey. So
I love that. I love that. So make sure to check out heatcraftrpd.com/regulatory to find out what's going on in your area. What do you need to go CO2? Can you go with an A2L? It continues to change. We're going to see it can change more, but it's up to us to learn those regulations. Grady, I want to thank you so much for hanging out with us today, and I'll see everyone at the next CO2 Mondays. Have a great one, Grady.
my pleasure. Thanks.
Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button, because when you do click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.